Okay, let's go to page 255, and this is section 21.6. This is transforming a function. So when you add parts onto a function, and it will do some kind of transformation. Okay, so let's go and compare the f of x. Okay, so if you look on page 255, there are three different functions. Okay. So let's say y equal to x. Okay, so in this case, okay, so you got f of x equal to that. Okay, and you got absolute value of x, and your absolute value of x plus 2. Okay, so if each other f of x equal to x, that would be just like y equal to x. Okay, so that would be just that. Okay, if you can go and make all different values, right? So you can have the like -4, -3, -2, -1, 0, 1, 2, 3, 4. You can do all that. Okay, now when you take absolute value, you're going to get 4, 3, 2, 1, 0, 1, 2, 3, 4, right? So for this one, okay, I'm going to color code for you. So for the red one, okay, what happens is, notice when it's negative, it becomes positive. So absolute value, so if you have y equal to absolute value of x, that means y cannot be negative. So basically what you have is anything below, it can flip it over to the top. Okay, so basically you end up with this kind of situation. Okay, so that would be the red. Okay, so again, absolute value means no negative. So anything below, anything got negative, it can become positive. So that's what the absolute value would do on the graph. Okay, so again, if you don't have absolute value, if you're just a regular function, you just graph regularly, right? Y equal to x, so you're going to get, so this is y equal to x. Okay, whereas over here you're going to get y equal to absolute value of x, the red one. Okay. So again, absolute value means anything below, it can flip it over. Okay. Now this part over here, I'm going to use, let's use blue. Let's use green. Okay, so yeah, absolute value of x plus 2. Now, in this case, what you do is look for the 0. Notice when x equal to -2, you're going to get 0. So over here, you're going to get 0. Okay, and then everything got shifted by. So if you just plot point by point, okay, you're going to get a graph. But instead of plot point by point, look for the 0. So when x equal to -2, so figure out when will this equal to 0. Okay, look for critical value. So x equal to, so you're going to get x equal to -2. Okay, so that means your graph, normally your graph would be like this, right? Okay, but because absolute value, because you just graph, so this one would be y equal to x plus 2. Okay. So again, you just graph regularly. Okay, another way to do it is by graphing regularly, and anything below you can flip it over. So anything down here you can flip it over. So you're going to get this one instead. Okay, so you got y equal to absolute value of x plus 2. Okay, again, so there are a couple ways you can graph these. Okay, one is you graph without the absolute value, and then anything below you flip it over. Right. So again, y equal to x plus 2. You're going to get the intercept of 2, and the slope will be 1. Okay, so you're going to get this straight line over here. Then, so you can graph without the absolute value. Just graph y equal to x plus 2. You get these. Then you apply the absolute value. So anything below, you flip it over to the top. Okay. So whenever you're doing the graphing, the easiest thing to do is just graph without the absolute value. Just go and graph without the absolute value. Then after that, you can go ahead and then you can go and apply the absolute value. Okay. Now, what if you have this kind of situation? What if you have an absolute value of x plus 2, let's say plus 3, okay, the blue. Then what? Well, so what you do is you graph this part over here, so that is this over here, right? So graph. So what you do is when you graph this, you graph this part only, okay? Okay, so you're going to get this line right over here. Okay, you're going to get this line over here. Then you apply the absolute value, so you flip it over, you get a green, right? Okay. Then so what you do is you work from the inside, you work your way out. Okay, so now this is the green. Now you apply this part over here. So this is y had to plus 3. So from here you go up by 3. So you're going to go 1, 2, 3. So you're going to be right over here. So your graph is going to look like this. Okay, and that's that. Okay. Okay, so you can sum up. Okay, when you have regular function, you just graph, and then when you have the absolute value, you graph regularly and you flip whatever is negative onto the top. Okay, and when you have this kind of situation, okay, so you can look for the 0, see where the corner is, or again you can graph regularly and whatever is negative, you flip it over. Okay. Now, if you have additional stuff on the side, okay, if it's a plus 3, then you just go up by 3. Okay, again, because this is y, right? Y equal to this plus 3, so you just go up 3. Okay. Okay, and this should be kind of straight. Okay. So this is where the 3 is. Kind of off a little bit. So once you understand the absolute value, then it's not too bad. Okay, the simple kind are not too bad. Okay, so let's look at the example. Let's go to some examples. So we kind of covered the 21-12, right? Again, if you have additional part, you can just shift it up, right? Now, the example 21-13, so you have if you have multiple function, so let's say you have a f of x and you multiply by something. So what did it do? Okay, well, so if you have a f of x equal to absolute value of x, then when you multiply by something, it means you change the slope, okay? But you just do the same thing, right? So the higher the slope would be kind of more like a V shape, okay? And again, it just affects the slope. So basically what you do is you just graph regularly and you just flip it over, okay? So instead of this kind of situation, if you multiply by a number, it may becomes like this instead. Okay, so it depends on what the multiplier is. Okay, so let's say a equal to 3, so you're going to get slope equal to 3. Okay, you can see, and everything gets flipped over to that way, right? Okay. And example 21-14, it gives you a equal to 2. So you have f of x equal to absolute value of x versus f of x equal to 2 times that, right? So again, instead of slope equal to 1, you just have a slope equal to 2. Okay, and then that's it. So the graph it looks like this, will be more compressed. Okay. Now, in then one thing you have to be careful is it kind of mentioned that f of 2 if you have a f of x, equals absolute value of 2x. Okay. So most of the time, okay, not always, okay. So f of x equal to 2 absolute value of x versus f of x equal to absolute value of 2x. Okay. Now, in this case, they are the same, okay, but not always, okay, because if the, let's say if the number is is different, like for example, like negative number or something like that, it may not be the same. So just be aware of that. Okay. So you can read the warning. It says, though the pictures result from 2 absolute value of x and absolute value of 2x are the same, a vertical stretch by 2 and a horizontal shrink by 2 are not generally the same thing. Okay. Especially if you have something other than like the square root. Okay. So example of that would be like a g of x. G of x equal to 2 square root of x, and h of x equal to square root of 2x. So again, they are not the same. So just be aware of that. So sometimes some function they are the same, sometimes they are not.